VLSos here. This is a video lesson on dilation. Dilation is a type of transformation. And a transformation is a change. It's to change to an equation. It's a change to a graph. There are many ways that we can transform equations and graphs. Dilation is just one. I have a graph of a function I'm going to call the f function, and I'm going to use it to show transformations. Dilations can come in two forms. We can stretch, which elongates distances, or we can compress, which reduces or shrinks distances. And we can stretch and compress horizontally by affecting the horizontal variable, typically x, and we can stretch and compress vertically by affecting the vertical variable, typically y. So let's give an example. If I have the f function, I can think of a transformation by multiplying the entire function by 2. So we have a new function twice the mathematics of the old. We don't know what the f function is, we don't have an equation for it, but we're going to dilate or transform the graph to see what the effect of multiplying by 2 is. Now we can describe the effect of multiplying by 2 if we group the 2 with the variable or the axis that it affects. It might be a little bit more helpful. This 2 is not grouped with the x inside of the parentheses. This 2 is affecting the vertical axis. It's going to be a vertical transformation or a vertical dilation. So it's best to group the 2 with the y because that's the axis it's going to affect. I'm going to divide both sides by 2 to group it with y. So this is going to be a vertical effect. It's going to be a dilation because it involves multiplying or dividing the variable. Dilations can be stretches or compressions. Which is it in this case? There's a counterintuitive thought when you approach transformations this way. If we are dividing y by 2, we think that division diminishes or reduces. But counterintuitively, dividing by 2 actually causes the graph to stretch. So it's a vertical stretch. Factor 2. Vertical distances are going to double. So what does that look like on the graph? If I have a point here at 1, the vertical distance is the y value of that point, or the distance between it and the horizontal axis. So a vertical distance, if it's going to stretch by a factor of 2, is going to stretch to become a distance of 2. We can think of this point stretching out and locating here. This point represents a vertical distance of 2. Its y value is -2. The distance between it and the x-axis is 2. And if we stretch it by a factor of 2, it stretches in the negative direction, but to 4. Every point between these two is going to stretch by a factor of 2. So they're going to stretch out their coordinates, and these 2 points will connect by a straight line. This point here that is on the x-axis has a vertical distance of 0. There's no distance between it and the x-axis if it's on the x-axis. So it doesn't move after a stretch of factor 2. Likewise, this location here didn't go anywhere after the dilation because it's on the x-axis. And this point, which is an x-intercept, will not move either. So these 2 points remain fixed, and I can draw a line between them to show how the rest of the points between these 2 points are affected. Likewise, these 2 points will be connected by a line that will continue. I'm going to shade so that I can better see the graph after the dilation. And hopefully, it's obvious that the f function was stretched out vertically by a factor of 2. Let's give another example. I can use notation y is equal to f of 2x to think about another dilation. So in this case, I have a 2, but it's multiplying x. So it's a dilation because it involves multiplication or division. What axis does it affect? Horizontal, because this 2 is grouped with the horizontal variable. But is it a stretch or a compression? Now this is where grouping the variable with the grouping the operation with the variable that it affects comes in useful. We don't have to solve for y because y is already solved for. The 2 is grouped with an x, and it's consistent that there is a counterintuitive idea here. This 2 is multiplying x, and we think that multiplication expands, but multiplying x by 2 is going to compress by a factor of 2. Horizontal distances are going to be halved. This is a horizontal compression, factor 2. What does it look like? Well, let's think of horizontal distances. This point right here has a horizontal distance of 3. It's in the negative direction. But if its horizontal distance is going to be halved, it's going to get closer to the y-axis. I'll put an x to show where this point was dilated to. A point that lies on the vertical axis does not have a horizontal distance. The horizontal distance between this point and the y-axis is 0. So after the dilation, it doesn't move. This point here has a horizontal distance of 5. The x value of this point is -5. So if its horizontal distance is halved, it's going to move to be -2.5, right there. This point has a horizontal distance of 1. Halving it would change it to 1/2. So this point was put in the wrong place. It should be here. Oh, confusing myself. We're talking about the original function. Trying to graph 3 functions on the same axis, not y's. Let's check this. This point was halved to become there. This point on the original function was halved to become there. Also this point, so my x's are good. And this point doesn't change. Connecting these 2 points, which moved here, I can draw a line between them. Connecting these 2 points, which moved here, I can draw a line to connect them. And connecting these 2 points, which moved here, I can draw a line that connects those. Hopefully we can distinguish this third graph from the original, and it looks like the original function was horizontally squashed by a factor of 2. Last thing to talk about, a different kind of transformation called reflection. We can easily perform 2 types of reflections mathematically. A reflection over the x-axis and y-axis. if we have the equation y is equal to negative f of x, then we're multiplying one of the variables by a negative, which has the effect of reflecting over an axis. Well, which axis? If we're given this equation here, we think we're multiplying by a negative, but what variable? The negative is not grouped with x inside the parentheses. It's affecting the y-axis, the vertical axis. So if we take a step to group it with y, then we can think over what axis are we reflecting by making y negative. It's counterintuitive. We see y, it's a reflection over the x-axis. Making y negative is an x-axis reflection. That means that the original graph would be folded across the x-axis. The top would fold down and the bottom would fold up. The other easy reflection to make is a y-axis reflection. We do that by making a variable negative. Which variable do we make negative to do a y-axis reflection? X. And it would look like this. Y is equal to f of negative x, takes the original function and reflects it over the y-axis. What was on the left is now on the right. What was on the right is now left.